Good afternoon, everyone. So I hope everyone had their merienda and their afternoon coffee and tea. So uh, let's continue with the afternoon session. So for this session, we'll have the industry talks. Before we start with the session, we would like to take a moment to recognize the generous support of the NEECECON sponsors, Advanced Energy, Techmark Keysight Technologies, Embedded Silicon Technology Solutions Corporation, Meralco, Analog Devices Incorporated, Presidium PH Corporation, Roden Schwartz Philippines, Alexan Commercial, Maker Lab, Samsung Electronics Philippines Corporation, and Challenge Systems Incorporated. So I am JB De Guzman. I'm part of the faculty of the UP EEEI, and I will be your moderator this afternoon. So to start with this industry talks, may I call on Engineer Philip Lagonilla from Advanced Energy.
Good afternoon. I'm Philip Lagonilla from Advanced Energy, one of the design managers, and the topic was for research and development of what are we doing. We're basically a power supply or power conversion company, designing power conversion products and manufacturing them. So for this afternoon, we're gonna talk about some introduction about AEI or Advanced Energy. We're gonna talk about the drivers that drives our R&D, what is the technology trends and what is required in the market. You're going to see how we develop power supplies. So we're not just in the designing of power supplies, so it's not just barely the design, but the total package of it. Also, we have this safety and reliability. We'll touch base on that. A little bit of our facilities in our markets, and then we'll show you a video. You may be seeing it in the ads, but it's basically a video of a summary of what we're doing in AEI, as engineers. Okay. Okay, straight from the internet. This is the AEI fact sheet. Basically, the highlight here is that Advanced Energy, we design and manufacture power conversion and measurement and control solutions. Okay, for our customers. So this is the core of what we do. But then again, when we say power supplies, let's say we were located in Eastwood. So anong ginagawa nyo? We're designing power supplies. Saan kayo? Eastwood. Ano kayo? Like a call center. So hindi nila malaman ano yung power supply. Ano ba yung power supply? One thing comes to mind pag sinabing power supply is this. It's the old school power supply. Actually, the power supply ng mga PCs ngayon are more aesthetic. They have good colors, modularized. But this is ang tingin nila sa power supplies. But actually, power supplies is more than meets the eye. All right. We cater to this industries: semiconductor, industrial, data center, telecom, and networking. So this is the base ng mga customers namin. So the power supplies really, old school. They are what do we call that? Unnecessary evil. No? So we were reviewing the slides. It's a necessary evil. While kailangan lang siya. Nothing is really being powered kung walang power supply. Okay? But right now, it's now getting technology-driven. Meron na siyang aesthetics. So nakikita natin siya in our chargers. The EVs, they look good. They're now exposed. They're also used in different applications like horticulture. So there's a different drive now on power supplies. But dati, sila yung mga nakatago. They're always embedded. We're always third-class citizens. And so, of course, that's being challenged with that is that we now design according to the space that was given to us, and we think about the technologies we put to deliver value dun sa customers namin. Okay, so for R&D, this is ilan lang naman R&D sa Philippines, no? But we're really R&D. We're coming into different markets. We do AC, DC, and DC-DC converters. We do chargers. We do inverters. And here, I already talked about the markets, but there are key drivers here that keeps us on our toes when we design power supply. So they are the conversion efficiencies, power density, how much you can pack sa isang size and get big power. thermal management, scale, and of course cost. Okay, so it's about basically it's about the triangle that it's coming around. It's not entirely new, but this is the challenge of the design. So one is density and efficiency. So there's always continuous research to be efficient. Customers want it efficient. For the server platforms, they want it they say yung mga more than 95, 96, 97, going to 98% efficiencies. And it's because I think the theme natin is sustainability. So we also contribute to that by delivering highly efficient power supplies. We contribute also to the world in terms of power conversion and electricity cost. Okay, so pa-compact ng pa-compact, and then they want it really all efficient. Next, drivers, we give value add. So we are we do creative and intelligent ways implementing new features, and so in terms of packaging, we use digital control now by using DSPs, and then we work with our customers closely by doing systems integration. So for packaging, really, for example, I work, one of my projects are more of telecom, we are really considered as like second to third class citizens there. So they designed their all 5G radio. Then we see the 5G radio, it's good, high tech, and then the space for the power supply is so odd shaped. And then meron mga requirements sila, specifications, that we are to design in that odd shape and still meeting yung mga dinideliver namin value. So one of the challenge there. And of course, cost. So we have to maintain cost competitiveness, and we do our own proprietary measures. We do modularization. We design for automation also, because even with the new technologies being discussed, it's still sometimes boiling down to the cost, especially if the customer is not willing to pay for it. So kahit na you have new technologies, you have GaN, you have silicon carbides, but they cannot pay. So okay, so that limits, and that's also one of our challenges. Okay. So trends is, the market is really going for low cost, the high efficiency, density, and scalability. So magka-contrast eh. They all want highly efficient. They all want compactness, and yet they all want it also at low cost. So those are really the three challenges that we're working on in advanced energy. So mahirap yun. It's not as linear. So if you also want value, that may value rin siya in terms of cost. Okay. For industrial power, we're working on three-phase power. We're trying to increase the power and power density. We're doing configuration and getting them modular. Also, we're looking into different cooling techniques, because yung iba dyan, like servers are all fan cooled. For the telecom, they are conduction cooled, so they are really fanless. And then they want it, like 10 years life, because our customers probably is based in Europe. Pag nag-conk out yung 5G radio, no one's gonna go there sa tower, di ba? So power supplies need to be reliable. So okay, so different cooling, conduction cooled. Okay, so for the open compute, we're working with industry partners. Again, the numbers here is more of efficiency. Okay. And those are the things that in the last bullet is keeping us in our toes in terms of R&D. Okay, so our focus is, again, driving for high efficiency. We do that by using high performance devices. That's silicon carbide or GaN. We optimize our magnetics design, so we use our simulation. We drive for low core losses, And we use simulation also so that we would know the core losses, the flux density, even before we build them. For power density, and there are always form factor challenges, like what I shared about in telecom, we're third-class citizen. It's not really a square or rectangle they give us. They give us semicircles in between. And then yung mounting pa ng radio nila, nasa smack in the middle of our power supply. So it is a challenge. But we're steadily increasing. So we're now, for greater than 60 watt per cubic inch for the 1U profiles. We're trying to get greater than 30 watts for three-phase power and 800 watts Ito for board-mounted bricks. Again, thermal challenges here. So we use in our simulation flow therm. For performance, we use proprietary solutions. We're just trying to not going into the details of this one, but in R&D we try to think of ways to give solutions to the customers. At the same time, since they're proprietary, we also get to invent things, patent things. So these are just the things we do for our customers. Okay, so how do you design a power supply? You start by doing simulation. We have simulation tools, so the more tools, the more fun. It's because even before you build the power supply, you already get to see the performance. So we simulate them block by block. We use some of the common, sometimes in the industry, MathCAD, the symmetrics, and we're able to see actually through our flow therm component temperatures. Okay, so before we even move to building yung actual power supply. So even before it's a trial and error na makita namin na it's gonna be hot, then we are able now to simulate that. And even in the PCB, we're trying to we can check the balancing of loops, and we have our best practices. Okay, so to start, to get a feel of the power supply, we have our 3D printing, so that we can have a look and feel in 3D to see the power supply itself. Here we have our own in-house assembly of magnetics area, so we build our own magnetics, so we wind them manually, we test them, because we test our design and then we optimize. Okay, and then we have multiple design teams working on the different business units that I showed you earlier. So we bench them. So it's in a way we get our hands dirty, because it's not really mostly a system level test. But we get to do soldering, we do bench work. And yes, may mga dyan, because of experimentation, we sometimes, it's part of the design. Meron dyan na maaring flaw, meron mga puputok dyan. So it's really fun, that you test your design. So, but it's part and parcel of being a design engineer. Okay, but more than that, since it's going to the market and being used by customers, we have to test them through our product safety. So no fire, no smoke, okay? So yung mga safety logos you see in the power supplies, because they're tested that way, because we ensure the safety of our customers. We also ensure the EMC, or the electromagnetic compatibility of that. We are compliant to the standards, so we test for that. And we design for that. And reliability, of course, like telecom power supplies, they need to last 10 years. So they have to be reliable. So they have to be standalone right there in the pole, up to like several European countries, up to negative 55 degrees, up to like 95 degrees base plate, kasi that's what the customer is offering us. You need to survive this 95 degrees. Okay, so we test for that. And some of the other things that it's not really being seen for digital. We have our own firmware development, so we do code as well. We do consistent manufacturability reviews, so not just your design is just designable in a way, quote unquote, and it just works. It has to be manufactured. It has to be repeatably manufactured. And then we do design verifications tests. So one of my principal engineers said the power supply is good as the tests you run on them. So we test, we test, we test. Okay. Then I mentioned earlier EMI, safety. And yes, the reliability, we test temperature, we test the altitude, like for telecom and 5G, about 2,000, 4,000 meters above sea level. Then we do shock and vibe, so that walang nahuhulog na mga components sa loob, and we check that. So it's really more than just paper design of things. We manufacture that. We have manufacturing facilities here too, actually in the Philippines. One is in Laguna and one is in Cavite. And one is in China. So really, it's all Philippine-based. And okay, our R&D is actually in the Philippines as well. It's in Eastwood. So we have just a snapshot of our buildings and our capabilities. So we do have our own EMC chamber there, so if you visit. Okay, this is what we do, actually. We do these products. One of them is actually for solar, one of them is for horticultural. So we just in our booth, we are lighting a plant. And so sabi nga ng vendor, our customers, that this LED is tuned to this plant. And so we power that. We power what's inside is also not being seen. We go into these products. We go into the medical. We go into the hospital beds. We go into these MRIs. We power lights. We do EVs, solar, and of course the server market. Okay, so we can do this. So Facebook here is for the servers. The plants are for horticulture, and yes, buildings, lightings, etc. So these are in our website. What you can see, these are our embedded products. They go into these target applications, the one at the bottom. We are covered, from the aesthetics, really, but, before those systems are powered, we power them by highly engineered power supplies. And to get a glimpse, again, I think it's a bit over time, to get a glimpse of what we do quickly, the next one is actually a video of what we do in advanced energy. Okay, all in a day's work at Advanced Energy. So the future systems that we see now is being discussed is actually, we're already in them before they're coming out. So let's power the future together with Advanced Energy, and thank you very much.
Okay. Any questions from the floor? Okay, sir. So ako na lang po magtatanong. So, tama po yung dinedesign ninyo for networks and comms na power supply. Yung that's what you mentioned earlier.
Yes, so different markets. So we go with industrial products, medical products, yes, server, networks, and telecommunications. Yeah, IT. Yeah.
Okay, so for the telco power supplies that you design, so do you actually do like system and then power supply in the loop sort of tests? say, for example, now we want to say move into a more energy efficient telco network. So you want, I guess, more controllable or more informed power management. So do you do those kinds of?
Yes, yes. We also work with our customers on that. If that is their platform, so we even develop tools, software that would help them monitor power supplies or go with the goals of their like their servers. Yeah. For telecom, since it's an emerging technology, actually they're very secretive. So even to us, they're not sharing their, let's say 5G. When it was coming out years ago, they wouldn't really share it. But we get to see the specifications that we need to do, and it's actually, different from like the server platforms or any other power supply. They do have very different requirement, and they're very stringent because since nasa labas sila, they're meant to be hit by lightning. So we need to survive that. They need to be, with power line disturbances. They need to, survive ice, wind, rain, and then still last 10 years. So that's where we put our R&D on that.
Okay, thank you, Engineer Philip.
Thank you.
So, we'd like to present this certificate of appreciation to Engineer Philip Lagunilla for sharing their invaluable insight and work on powering the future with advanced energy during the National Electrical and Electronics and Computer Engineering Conference given this 19th day of July 2024 at Novotel Manila, Quezon City, Philippines. Signed by our director from the UP EEEI. Okay, for our next presentation, let me call on Engineer Larry Mirasol from Rodan Schwartz, Philippines.
Sure. Good afternoon, everyone. Today, I'll be discussing understanding EMI pre-compliance testing. And before we begin, I have a few I have a customer here, Sir Erickson, and he's my main customer regarding EMC. He's my number one EMC customer here in the Philippines. So today we'll discuss EMI pre-compliance testing. And first of all, we need to discuss what is electromagnetic compatibility test. So before we sell our products that we develop worldwide, for example, you have a target market in Europe, US, Japan, you need to certify your product in that market. So that's what EMC testing is all about. So we have EMI, wherein we need to measure the noise or the noise that our product is contributing to the environment. So it has two parts. It can affect other products through contacted EMI or can also be affected by radiated EMI. So we need to test both EMI and EMS. Okay. So in conducted EMI, we test the noise coming out from our DUT through conduction. While in radiated, what is being radiated in the environment. So aside from that, we need to test our product also to receive the EMI noises in the environment. Both also can have conducted in the radiated EMS. So these are what electromagnetic compatibility is. So yeah, we have several standards like CISPR. So in CISPR, we have according to our DUT, kung ano yung DUT natin, doon natin siya itetest. For example, scientific and medical equipment, we use the CISPR 11 standard. For household equipment and electrical tools, we use Sister 14. For lighting, we use Sister 15. And for multimedia equipment like our cell phone, laptop, we use Sister 32 standard. So in compliance testing, we need to have that chamber. So we have one from RTC in Advanced Energy. They have this chamber. And also we have full compliance chamber in EPDC in Bikutan, Taguig. So that's the compliance setup. You need to have that environment wherein there's no other EMC noises available in the area. So yeah, we only need to measure the noises coming out from our DUT. Okay. So this is the process of EMC testing process. So first of all, we need to develop our product. And then after that, we do the prototype. And after the prototype, we need to certify it before we sell it to outside the Philippines. So before you send your equipment or product, you need to do pre-compliance tests because you can't. This compliance test is very expensive. So if you fail, you need to restart again. So you need to do pre-compliance testing first and pass that so that you have level of confidence that you will really pass the compliance testing. So this is one example of conducted emission setup wherein we connect our EUT or our product into the LISN, and it is connected to the receiver which measure the noise or the EMI noise coming from our DUT. And this one are the pre-compliance setup, minimum pre-compliance setup that we can do in your lab. For example, you cannot afford to set up a big chamber. You can just get a GTEM and do the testing inside. Since GTEM is cheaper than a big chamber. And for the receiver, you can buy a pre-compliance receiver or even some spectrum analyzer you can also use. And you can also use oscilloscope that can do FFT to do your pre-compliance testing. And here in the Philippines, those R&D, power supply R&D companies that are setting up are usually doing this kind of setup. But for our advanced energy, they do the chamber. They set up the chamber. And some also other in Cebu and upcoming in Batangas, there will be also a new setup that will itatayo siya. Next. So ito yung mga equipment na pwede natin gamitin for our pre-compliance and the difference between them. For example, we have EMI receiver wherein it is being used for full compliance testing. You can buy this, or if you don't have enough budget, you can buy a spectrum analyzer, or if you don't have budget for a spectrum analyzer, you don't have one, you can also use an oscilloscope. So what's the difference between them? First of all, sa tatlong yan, ang pinakamahalaga na factor dyan yung preselector ng EMI receiver. Usually, ang EMI testing, hindi natin alam kung gaano kataas yung mga EMI noises. So we really need the EMI preselector para ma-block natin yung mga sobrang taas na signal and hindi siya maka-apekto sa measurement. So yung spectrum analyzer, wala siyang preselector. So ganun din yung oscilloscope. So yun. Kaya hindi rin siya pwedeng gamitin for full compliance testing, yung dalawa na yun. Usually ang ginagamit yung receiver talaga. And time domain scan, new receiver nowadays have this time domain scan which make the testing very fast. So from few hours, ngayon mas mabilis na yung testing ng radiated emission. For example, used to take a few hours. Ngayon, maybe seconds or minutes na lang siya. Yan. And I will not go to everything. Next. Ito naman, EMS. Since our product, katulad nung sinabi ni Sir Philip kanina, they need also to check yung kung gagana ba yung kanilang product sa mga harsh environment. So, being subjected to electrical noises, so ito yung test ng EMS. Sinasubject natin yung DOT natin sa mga EMI noises coming from other equipment, or for example, there's a strong broadcast signal outside, then it should not be affected by these noises. So kailangan resilient yung product na ginagawa natin. Okay. Next. So ito yung para dun sa radiated. So aside from the radiated, we also have conducted EMS. So yung DUT natin, isa-subject naman natin siya sa sa conducted na through wires naman yung pag-apply natin ng noises. So yung kanina is through radiated, this one conducted naman. So ano yung mga gagamitin natin para para i-expose yung DUT natin? So meron tayong CDN, EM clamp, saka BCI, bulk current injection. And yung mga components natin dyan, gagamit tayo ng signal generator, power amplifier, and power sensors. So yung power sensor, may measure rin naman niya kung ano yung level nung signal na ibabato natin to check kung tama ba yung sinasubject nating signal dun sa DOT. So, for another naman ng pagtetest ng pre-compliance is we can use near-field probes. I have a demo outside and I'm showing it in our booth. And also LISN, line impedance stabilizing network. So, yeah. So, any question for understanding EMI pre-compliance testing?
Sige, Sir Larry. Yung dun po sa device under test, ano yung mga examples dun sa electromagnetic susceptibility, usually?
Okay. Examples. First of all, examples is madalas ko siyang makita or yung client namin, like Advanced Energy, power supply. Basically, tinetest nila yon na either conducted or radiated, na resilient siya sa EMI noises. The previous one is military standard. So meaning, in that setup, they will introduce noises sa DUT nila, and it should not affect the operation of their power supply. So if your power supply have internal communication, then that communication line should not be affected or can be handled correctly by your power supply. So it should not malfunction during EMS testing.
Okay, thank you. So, would like to award this certificate of appreciation to Engineer Larry Mirasol for sharing their invaluable insight and work on understanding EMI pre-compliance testing during the NEECECON 2024, given this 19th day of July here at Novotel Manila, signed by our director. Okay, and for our next industry presentation, let me call on Engineer Eugene Lativio from Presidium PH Corporation.
Okay, good afternoon. So, by the way, I'm Engineer Eugene Lotivio. So, I'm from Presidium PH Corporation. My discussion is actually about the illuminating efficiency, energy audit, and their environmental footprint. So, actually, it's a broad topic, but I will try to make it short. Okay. Okay. So, the question is how would you know if you had a savings opportunity in your facilities? Okay, but because nowadays po, we are trying to look for the savings, lalo po sa energy. And of course, we have a lot of solutions, and that solution, sometimes we don't know if is it efficient or not. Okay, so sa Fluke po, we have a different type of solutions like energy logger. We have a different test instruments that you can monitor your energy. Because according po sa ating RA 11285, kung makikita nyo po, this is all about the energy audit. Okay? Then, and why do we need to do an energy audit? Basically, most of the time, we invest a lot of equipments, but sometimes we don't know how to maintain it. Okay? Because sometimes, nowadays, like for example, we are using the LED. Why LED? Because it is related to the power. Okay? Before we are using the incandescent, but that is an old and traditional light. But nowadays, due to the pace advance of the technology, we use the LED. But sometimes we don't know the graph or the effect of those technology on our raw power. That's why the Fluke has a test instrument to check those graph. Okay? And in terms of energy audit, you have only 3 steps lang. Okay? That is, one is to commit. Of course, you have to commit energy savings, access current energy performance, and prepare for an energy audit. Yan. The next, of course, execute. Okay? So you have to conduct the energy audit, that is, quantify the savings potential, create action plan, and implement the improvements. So if you check the other solutions, most likely like the installing cap bank, installing power inverters, etc. Sometimes we don't see the power problem or power quality issues. Okay, so one of our customer is from the Advanced Energy. They have a thermal imaging, no? So that's a very good product on our part because they want to see the temperature difference of their PSU. So we have a lot of solution actually on Fluke. So it's a broad and a large topic. Okay. The next is sustain. So if you have you're trying to execute the energy audit, of course, you have to sustain it. Just sustain and continuously monitor improvements and, of course, verify savings. Okay? And as you can see, we have a different use about the energy. And the direction of the government is actually, it's more on the renewable energy. And we have a lot of problems about power shortage. We have a lot of problems coal and etc. Then, of course, we have to start on the lower part, a simple community like a simple barangay. They should be aware on their energy consumption. Kaya nga we have some news na tumaas ang kuryente, meron some news na bumaba ang kuryente. So it depends, no, how we consume our energy. But the direction of the Department of Energy and other government third body, isa lang po ang kanilang goal, okay? To have an energy savings. And of course, you can check those if you have an instrument like Fluke, okay? And of course, according po sa DOE, Filipinos' awareness on energy savings increases. Yes. So, papansin po natin, every summer, mainit, then we turn on all of our air conditioning. And, of course, our consumption, of course, will go high. So, but of course, with the savings, it could help on our sa maintenance, facilities, and etc. And actually, we have a different type of a Fluke Energy Assessment Kit. Okay, so this one that you can use on your energy, like for example, the lux meter or the light meter. Sometimes, we use the LED or CFL or etc. But we have to check the lumens, okay? Kasi we don't want to be super bright. Okay, like for example, in this hall, in this room. So, there are different lumens, okay? So, meron po si Fluke po niyan. And multimeter, and basically, clamp meter, and ultrasonic, thermal camera, airflow, three-phase logger, thermometer, temperature, and humidity meter. All of those Fluke as a kit ay ginagamit po yan for the energy. And of course, si Fluke, hindi lang po, it's more on energy. We have products that can help on your applications like on the power electronics. We have a thermal camera that are focused on the electronics. Okay, so I think it is a separate discussion. But of course, as you can see, here's the different product of our company. That is, as you can see, we have the leak detector. So nowadays, most of the leaks on the semicon company, they are using the pressurized piping system. Sometimes they don't see the air leaks. So we have the ultrasonic leak imager that you can see in instant of your air leaks, okay? As long as it's pressurized, okay? Then we have a lux meter, multimeter, and of course the power logger, okay? So, ayun. So, again, thank you so much and hoping you have the idea on our products. Any questions?
Any questions from the floor? Okay, Engineer Eugene. So, question ko po, dun sa yung Presidium Beach, aside from providing Fluke and the actual like instruments, do you also provide like energy audit as a service? As in the audit as a service, do you provide it as a
Okay.
service?
For the energy audit service, we have a partner to do that. Actually, the company is a provider of a test instrument, but good thing on our company, we provide solutions. Like for example, how to use the product itself. And of course, we have a lot of actually seminars, trainings about the energy audit. So we are trying to help those company or in servicing company that what Fluke products that can help on their energy audit. Even private company, government. So we are trying to do but the services is not our scope.
Any other questions? Okay, so thank you, Sir Eugene. So we'd like to present this certificate of appreciation to Engineer Eugene Lutivio for sharing their invaluable insight and work on eliminating efficiency, energy audits, and their environmental footprint during the NEECECON 2024, given this 19th day of July at Novotel, Quezon City, Philippines, signed by our Director, Lou Andrew Tria. Okay, for our last industry presentation for this afternoon, may I call on Engineer Adrian Tolentino from Analog Devices.
Good afternoon, everyone. So I'm Adrian Tolentino from Analog Devices. So I'm the manager of BMS Systems and Applications Engineering in ADI. And my presentation is on earlier development, faster time to market, and more sustainable EVs or electrical vehicles through battery management system emulation. So it's a bit wordy, so please bear with me. Okay, so this is the presentation outline that I have. So what we want to answer is ADI is a semiconductor company, but why are we making or why are we doing emulation? So we can tackle that in 4 points. First is we need to establish that ADI now is moving up the stack or the value stack. And then I'll give an introduction of what the ADI's BMS emulation is. And then I'll go through the benefits that the customers see on the emulators, and then we'll have a showcase or a touch base on the R&D in ADI. So what does moving up the stack or the value stack for ADI mean? So as a company, ADI's purpose is to enrich people's lives through signal processing technologies and transforms people's experience with technology by bridging the analog and the digital world. So we are able to drive that purpose by building the solution stacks, okay? But since ADI is a semiconductor company, and in order to be able to create solution stacks, we need to develop on the technology or the core technologies that ADI has, and we start that with creating the embedded technologies, digital and software. On top of that, moving up to the solution stack. Okay. So how does ADI do that? So I'm going to show you an example of how we do this on the automotive side. So this is an example of the emerged technology that ADI has pursued. This is the wireless battery management system. So traditionally, we know battery management system to be a wired system, but ADI has ICs or integrated circuit products for this. Basically, in order to create the wireless battery management system, we need the RF transceivers and then the battery management system products itself. But as ADI moves up the stack and bring more value to the customer, we need to develop modules, or for this case, we have the ADI BMS eval kits. And then moving up the stack, we need to support the customer's needs in order to be able to give them the measurements, analytics, and ultimately the service of the service for the wireless battery management system. So moving forward, as I've said, with just the ICs that ADI is able to give, we are limited to the value that we can give to customer. But as we move up the stack, we are able to give value beyond the silicon. So because we have the whole system solution, we are able to provide value in manufacturing, life cycle monitoring, flexibility and user experience, and on the second life for our electric vehicle batteries. So now, I'm not here to talk about wireless battery management system, but I'm here to talk about something that's on the embedded layer, or something that's above the core technology layer of ADI, which is the battery or the BMS emulation. So for the customers actually need to learn features of the battery management systems that we offer immediately. And then there's a need for them to start software development with or without the actual BMS ICs. And then there's also a thrust for innovation on their side, on the battery itself and the battery management system that they are developing for their specific products. And then they need to develop and validate the functional safety concepts that they develop. So in the center, we are showing you the customer development phases wherein we're able to bridge to the needs of the customer. So this is early software integration and testing. Hill or hardware-in-loop BMS controller validation, fault injection and FUSA or functional safety testing, full battery stack validation, complete BMS family testing, and then lastly on the model verification. And that brings us to the end-of-life testing. So as I've said, with just the ICs, we can only bring them to the Hill BMS controller validation. But because we're moving up the stack, we're also able to give value through model verification. And this allows the customers to innovate their own battery management systems. So what is ADI BMS emulation? So let's start first with the traditional concept of validating or evaluating their own BMS. So when they do this, they have a setup for a conventional rack for Hill test solution, and they integrate that to their own battery management system. So for example, if the customer chooses us for their solutions, there goes our ADBMS eval boards. So this means that we need the actual hardware integrated into this bulky and expensive test rack. And this is actually an overkill and inconvenient for them, especially on the earlier developments. So what we wanted to do is to emulate all of that. Just have that big Hill or HIL test rack and the BMS itself in just one module, okay? And this allows us to actually simulate the whole battery pack together with the BMS solution. This means that with the BMS solution or the emulator, we're emulating the whole battery pack and the eval board for the customer. We're able to inject a lot of use cases for this one. So for example, this one, we're able to detect electrical measurements or even faults. The faults that we're able to detect, for example, is the battery shortage. And then we're also able to detect high current faults. And then there's also the use case of over temperature, which actually, as in the earlier presentations, this is the killer for the battery management systems. And we're also able to inject under temperature faults. There's also the case of isolation resistance simulation and eventually the fault testing for that one as well. And then there's also the open wire detection and open wire fault analysis. So basically, all of this is, we're able to do all of this with just the emulator itself, without using an actual battery pack, without using an actual conventional hardware-in-loop test rack, or even without the actual BMS hardware. Okay, so moving forward, the key features of the value that we are able to bring in for the BMS emulation is that it's portable alternative to the Hill racks. It's available months before the actual first release of our BMS products, specific for a customer. And then it can emulate the whole BMS pack. So you just need one device in order to emulate a device that consists of 22 BMS ICs daisy chained together. It also implements all positive and negative fault injections. And then it's field updatable, so meaning you can actually program it on the test use case that you want to do. And then it supports our proprietary ISO SPI and SPI connection so that customers can use whatever they need to use. So basically, that's basically the BMS emulation development that we're doing. Just to close that discussion, the BMS emulation is actually an ongoing development. We basically just get the requirements for a customer, develop that, and give them also feedback to them what ideas we have in order to develop the solution further. and then that cycle goes on. And it's actually the same on all the other application focus of ADI. So we have application focus on digital factories, automotive, digital healthcare, immersive consumer, 5G, next-gen connectivity, and autonomous transportation. So lastly, these are the latest developments of ADI on the high-speed signal processing platform. There's also the ORAN, compliant radio unit platform. So ADI started from just the ICs, and then we're already moving up to platforms. And hopefully, eventually, we reach to the level that we're able to deliver services for our customers. So that's all. Thank you.
Any questions on the floor? Okay, we have Sir Chicho. I think there's a microphone in the middle.
No, I'm just curious, no, with the battery management systems. Are there actually activities going on here in the Philippines that require that kind of technology?
The quality, we haven't actually reached out to any customers here in the Philippines yet. But with the battery management or the EV development, I believe there's charge as well, and there are other efforts that is tied with the university.
Yeah, thank you.
Okay, thank you.
Thank you, Sir Chicho. Another question from the floor?
So about the BMS emulator, do you use the for the emulator? Are you emulating the battery or just the BMS? Because
Yes, the emulation actually includes a model of the battery inside as well. So because of that, we're able to simulate use cases for example, unbalanced cell battery voltages, and customers or even internal in ADI, we can explore different how should I say this, different approaches to balancing the battery packs using our products.
So is the battery just certain models, or are you trying?
That's something that we can't disclose yet, but basically it's a platform wherein we can develop our own battery models as well.
Thank you.
So, Engineer Adrian, is the BMS ECU, is it only for analog devices, or is it like available for use for like universities or other
Okay,
organizations?
Currently, the emulation or the emulator platform itself is being marketed to our customers, but I think that's going to be a discussion with the marketing people. But if there is interest in the university or other institutions here about the emulation that ADI is doing, you can actually contact us for it.
Okay, thank you. So, we'd like to award this certificate of appreciation to Engineer Adrian Tolentino for sharing their invaluable insight and work on earlier development, faster time to market, and more sustainable EVs through battery management system emulation during the NEECECON 2024, given this 19th of July 2024 at Novotel, Quezon City, Philippines, signed by our director, Lou Andrew Tria. Okay, so that's our last presentation for this afternoon. And before we end this session, once again, we extend our heartfelt gratitude to our sponsors, Advanced Energy, Techmark, Keysight Technologies, Embedded Silicon Technology Solutions Corporation, Meralco, Analog Devices Incorporated, Presidium PH Corporation, Roda and Schwartz Philippines Incorporated, Alexan Commercial, Maker Lab, Samsung Electronics Philippines Corporation, and Challenge Systems Incorporated for their invaluable support to the NEECECON 2024. So again, I'm JB De Guzman from UP EEEI. So thank you for joining us this afternoon. So I now close this session. Thank you.